Now, in the course, we've talked about the idea that we're going to use more exact values for calculations. So, and that means a lot more ideas about using surds and using pi, and later on we're going to use e as well. So the idea here is we want to calculate exact values of some trig values, some trig angles. Now the ones we want to deal with are a 30 degree, a 60 degree, and the 45 degree. So you can see in the table there. We'll talk about 0 and 90 in a minute. But how do we generate these exact values of 30 and 60? Now, how you remember it's going to be up to you. If you want to remember the table as such, I think that's pretty hard. If you want to try and play around with your calculator, I think that's a little bit hard at times as well. The easiest way I think to remember how to get these is actually visualizing this triangle, and that's how I manage. That's how I'd go about it. So that's why I think I'm pretty typical in that. That's how I would remember it. So it's where probably easiest for most people. But the idea here is that what we start with is an equilateral triangle of side 2. So that side's 2. We've got our side 2 there, and this would be a side 2 as well. And then what we do, we're going to drop a perpendicular. So it's an equilateral triangle. When we drop the perpendicular there, those would remain at 60, but those would become 30 degrees. So because it drops and splits it in half there, this splits in half there. So we've got a triangle here that would have a 30 degree angle and a 60 degree angle. Now, the base here is 1, the hypotenuse is 2, so by Pythagoras' theorem we get this side being root 3. Now because we've got the 3 sides in the triangle and those 2 angles, we'll now be able to generate the ratio for sine of 30, because we can look at 30 degrees as the opposite side over the hypotenuse, so that's where the half comes from. Cos of 30 degrees would be root 3 on 2, because it's the adjacent on the hypotenuse, and tan would be the opposite on the adjacent, so 1 on root 3. So that's where we get the exact values from. We get 1 on root 3 there for tan, because it's the opposite on the adjacent. Opposite, adjacent, and hypotenuse for the 30 degrees. Now for 60 degrees, well, our opposite and our adjacents swap around. Root 3 is now the opposite, 1's the adjacent, so sine of 60 becomes root 3 on 2, so the opposite on the adjacent. Cos of 60 becomes 1 on 2, so because it's adjacent on the hypotenuse. And tan of 60 degrees gives us root 3 on 2, root 3 on 1, or just root 3, because it's the opposite on the adjacent. So that's where we get our 30 and 60 degrees. Right, an equilateral triangle, drop the perpendicular down so we get a right angle there. We've got our 60 degree angle. The top angle gets split to give us 30, and we've got a base of 1 because that side gets halved. Hypotenuse of 2, and root 3 comes from Pythagoras' theorem now for our third side. Now for 45 degrees. So for 45 degrees, well, this time we're going to draw an isosceles right angle triangle. So of side 1, the equal sides are 1. So that makes that one 45. That one makes that one 45, because if they're opposite, they're equal sides, the sides angles opposite equal sides are equal themselves. So that's 90 and 45, so that must be 45. And by Pythagoras' theorem again, our hypotenuse would be root 2. So for sine of 45, well, you can take your pick of which 45 degree angle you want to pick. So that'd be 1 over root 2, the opposite on the adjacent for this sine of 45. And it worked the same for the sine of 45 there as well, opposite on hypotenuse. For cosine, or for 45 degrees here, it's the adjacent on the hypotenuse, which is 1 on root 2. So notice that cos of 45 and sine of 45 are the same, which makes sense because the opposite and the adjacent sides are exactly the same. So tan of 45 is the opposite on the adjacent, which gives us the 1 over the 1. So you've probably seen that a bit before when you've used it in applications in the junior school. So there's the 45 degree angle ratios, and that's where we get them from. Isosceles right angle triangle of sides 1, hypotenuse of root 2, and the angles are 45 degrees. Now for 0 and 90, what you start to notice is that we get either 0 or 1. Now these ones can be given to you on your calculator. Your calculator is not going to give you a nice value for 1 on root 2 or root 3 on 2 or root 3. You can start to recognize them if you want on your calculator, what they start to look like, but they won't give you a nice fraction, and then it gives you decimal approximations, where if you look at for sine, cos, or tan of 0 and 90, it will give you either 1 or 0. The only one being tan of 90 degrees is undefined. So, and I think you've seen that before. You can't get tan of 90 degrees because basically you can't have a 90 degree angle with an opposite, and you can get a rise, but you can't get a run there. So when you look at a vertical line, so that's where you're going to get the idea that's undefined there for that one. So your calculator will give you an error for that one. But otherwise, sine of 0 is 0, sine of 90 is 1, cos of 0 is 1, and cos of 90 is 0, and tan of 0 is 0 as well. And you see the tan of 45 was 1. Hopefully you notice, because when tan gets larger and larger, it starts to approach infinity. So that's why it can't approach, it doesn't get any value for tan of 90. So there we go. There's your exact values. We've got to be able to put these into play in a lot of questions. So you have to remember these values somehow. As I said, you can either remember in your table, try and remember them with your calculator and get your relationships there, or remember, as I do, remember the triangle and try and apply that that equilateral triangle or the right angle isosceles triangle there to get those, and just visualize that triangle. The more you do it, the better you get at visualizing that triangle. So there we go. Be able to use them, be able to apply them as we go through the course, because the questions will ask you to leave your answers in exact form, and it'll be dealing with 30, 60 or 45 a lot of times in those questions.